Okay, so you were able to get your light to flash when you shook the magnet through the coil? Did that work okay? Oh, you're still working on, oh, you're getting ready to mount the capacitor. But you did get the LED to flash? Let's see, you're muted. Let me unmute you.
Sorry, I didn't know we were muted.
Yeah. Okay, so you were able to get the LED to flash, okay, right?
Yeah, it was flashing just fine.
We have a bit of
Okay, so great. We'll go on and let me do the next step here with you. We're going to
What's up?
magnets,
The magnet wants to stick to everything.
yes.
especially all our pliers.
No, that didn't arc too bad, buddy. You did all right.
Well, it had some arc to it.
Okay.
Yep. The what?
Okay, so we're ready to move on here and we're going to mount the capacitor. So let's talk about the capacitor a little bit. It's also a polarized device, so it must be installed correctly for it to work on our circuit. And the capacitor is just like a rechargeable battery. So as you've seen, every time that you shook the magnet through the coil, the LED flashed. Well, that wouldn't be a very good flashlight because it'd be a strobing flashlight. Maybe it would be a good flashlight if you wanted a strobing flashlight. But that little capacitor will allow it to store up some energy. And then every time you shake it, the excess energy that's not used to light the LED will be put into the capacitor and charged up. Now, capacitor is not a very good rechargeable battery because it can only hold charge for a matter of seconds or maybe up to a minute for a very large capacitor, but it can't hold like a battery for hours or for days or for weeks or anything like that. So it's a very purposeful rechargeable battery for a very short period of time. So on the side of the capacitor here, you will see that there is little minus signs. That's the negative side. And again, the short lead is the negative terminal on the capacitor. And on there, on the printed circuit board, you'll see that there are two little parts that say cap plus and cap minus. And on that, you will want to match up the holes with the short lead with being the cap minus and the long lead being the cap plus. And make sure when you install that, again, we're going to have to put that on the circuit board and be able to bend it over the end of the board, okay? So we want to be able to slide everything into the end of it. So we want this to be one long component here of all of our electronics to be able to slide it inside the tube. So install those two leads and then you can bend them out like a 45-degree to kind of hold it in place.
Just like before.
And then you're going to solder that. Just make sure, again, the cap minus is the one with the short lead and the one that matches up with the little minus signs on the edge of the capacitor.
Let's see if we can flatten that a little bit. I want that capacitor to be loose for sure. You ready to try this? Sorry. No, shake it. What are you doing?
I thought you meant to.
I said solder it, not shake it.
I bet.
Yeah, you want to solder it up there and then you can shake it.
Right.
And cut it.
True.
And then get it in here. So why don't we have much tape on it? This has so much.
You'll have a lot more tape on it when we're done. You think so?
There's a little wire sticking over here.
It's okay.
Could we cut it?
I have a quick question for you.
Yes.
The solder we have is 95% tin, 5% antimony. It seems to be a lot harder to work with. Is that
Yes, you have lead-free solder.
right?
And lead-free solder is very difficult to work with, especially for hobby stuff. It is
Yeah.
requires a much hotter temperature to melt, and the lead in solder makes it really soft and malleable, and it flows really nice. And the lead-free solders tends to be what we call stringy. It has what we would describe as cat whiskers. They come off, and it's kind of follows the iron and doesn't puddle up nice. So it's a little bit harder to work with.
I was just curious because we've been kind of fighting with it.
Yeah, and it just doesn't as work. All of our electronics that are commercially made use lead-free solder to comply with the Environmental Act. We throw tons and tons of electronics away every year. With our recycling efforts, we collect some of that, but there's still a lot of it that goes into the landfill. And so lead-free solder is the standard for all of our commercial electronics, but for hobbyists, it's very difficult to work with. It takes a little bit different equipment to really do a good job. So hobbyists still use a lot of lead-based solder. We tend
That
not
makes
to
me
throw
feel a
our
little better.
projects away at the end, so probably environmental concerns are a little bit lower.
Minimized, if not eliminated. But, like I
And
said, I
then
feel a
don't
little
forget
better
to
about
trim the little leads off the excess again with your electronic nippers there, so you'll be able to trim those short.
What kind of?
it. Let's see.
And once we get those trimmed short, our goal is to slide the printed circuit board with the capacitor towards the little rubber bumper. And we're going to put the wires down the side of the capacitor. And you'll kind of have to work with your hands there to slowly pull the wires back through the hole, back out the end so that the excess wire is outside of the tube. And you don't want to jerk on that very hard, but carefully with your hand, push the printed circuit board in and use your hand to pull the wires out of the little hole on the tube there. And you'll eventually get it down there. And we want to get that LED past the end of the tube so it's not sticking out where it would get hit or damaged on anything. Okay, and once we get the wires put into the tube there or pulled out of the tube and the printed circuit board into the tube, what you can do is you can spin the coil around the edge or the outside there and kind of twist up the wires and take up the excess wire around the tube. And that will help hold that in place and use up the excess wire there.
So that explains a lot.
Yeah, that's gonna be a problem.
Can we get back? One of our wires broke.
Okay, so this is a good time that you can restrip that wire and bend another fish hook on it and solder that up there on that connection.
Oh yeah.
For a second, we thought some of our solder was touching on the circuit board thing.
All right. You want to strip this one real quick? You've done a few of them. Why?
Okay.
Yeah, you can strip it, bud. Ian's actually let me find it out so it doesn't catch.
And just remember when you're removing your insulation there to only squeeze your pliers hard enough to cut through the insulation, not nick the conductor, because that makes it weak. And it'll break off at that little nick point if you squeeze it a little bit too
Yeah.
hard.
Nope, in the notch. There you go. Nope. Buddy, stop moving. Stop. Okay. Very well there. Good. You're squeezing too hard. Don't squeeze it hard. Nope. You're on the end now. You move. Let go. Come back to where you were. Right there. Now, just a little bit. You can't really move it as much as we did before, but don't do that. You're clamping too hard. You're having a hard time not clamping too hard. We might need to set this for you. Stop. All right. Let's see if we make the wire at all. Actually, I think we're all right. All right. Make your little hook. Remember how to do that?
Yes, but
No, I'll worry about that in a minute. Make your little hook there. Use the pliers, don't use your fingers. No, you want to bend it at the insulation. It needs to be straight and then hook. So straighten it back out first. Let go. There. Straighten it back out first. Bend it about halfway down. Nope. Buddy.
it's breaking.
Yeah, no. Yeah, all right.
Get it.
I know.
It didn't want to.
What's that?
I think the wire was already pretty nipped. I think that's why it wasn't wanting to.
The trick. Grab it, but you kind of curl it here instead of. So you're turning at a larger radius. You need to kind of curl it.
I should have gone like this. Instead, I was going.
Right. And by turning at that larger radius, you put the stress down here instead of force bend up here. Okay. All right. Let's see if we can get this old one out of here. So what I want you to do. Hey, stop fiddling. Okay. You do this. I'm going to heat up the old solder, and I want you to pull this piece of wire out when it's warm. Okay.
Got it.
So you hold this. All right. Good. No, not with your finger. Come on, man. That's hot. You don't do it with your finger. Other side. Nope. You can't pull it towards the tube. Grab the other side. Go ahead and pinch on. Okay. Go ahead and pull. Almost. Well, pull it out. There you go. All right. Now I need to hook the new one through there. We'll heat the solder back up. All right. So heat that through.
Hey, I think I did the magnet thing.
All right. Now.
Look, it's working
Okay.
as a magnet.
Okay. Pinch that down with those pliers. Come on.
Come on.
Here, we'll move it away from the magnet a little bit. Get a good solid joint. There you go. See now how it won't come off without solder, right?
Yep.
Now there should still be plenty of solder on there. Let's see if we can just here. See watch what I'm doing here. We're just gonna heat it up. Try and kind of move it back down, right?
Looks like a sheet of paper. Maybe.
A little bit, right? Liquid metal, which is essentially what it is.
Yeah, you may need to add a little bit more solder to it just to get a good connection again.
I think we had a little more than we needed the first time.
Okay.
This is the pliers are kind of magnetic right now. and
Yeah.
I'm pretty sure. Yeah, explain that in the electricity book.
Yeah. So metal, if we take a magnet and move it over the metal tool in one direction, we line up all the um, ions inside the metal, and it makes them magnetic. And so if you have a screwdriver and you want to magnetize it, you just take the magnet and stroke it over the screwdriver, and it will magnetize it. And if you want to demagnetize something, if you drop it on the floor, it'll give it enough shake to it that it will probably demagnetize it. It makes all the little particles go different directions. And so that demagnetizes something.
Hey, Mom, look at this.
All right, buddy, I think we're at the taping phase.
Okay, so our taping phase here, we want to center the coil in between the little rubber bumpers. Okay, so you can visually center it, or you can use a little tape measure or a ruler to help you, but you can use the magnet to kind of move back and forth and see here the void that's in between the magnet and the coil, and then move the magnet to the other side and kind of see where that is. And so we kind of can use that as our visual to help us center that onto the end.
As far as it goes. That's as far as it goes.
Now there's several different ways that we can hold that coil in place. One is just to take a long piece of tape and then kind of tape over the coil here, just in a strip to hold it in place. The other way is to take a band, just like we did with the straw, and wrap around below the coil and hold it in place. And that may be a little bit neater, just to kind of give it a, I'll call it a speed bump or a roadblock there. If we take a 6-inch or 12-inch piece of tape and wrap it around just in a band below it, that will help hold it in place so that does not let it slide down the tube. So either way of taping it to kind of help it get into the right place for alignment is acceptable. Okay, any questions on that part?
Which way do you want to do it? The two ways you were just talking about. Which way do you want to do it?
Here's one way of taping it long over the edge and right down back to the tube so that it just kind of holds it in place. Or you can do it just like you did with the band around the straw, holding that in. And I would put it right down here, like where the 1-inch mark is on the tape measure here, and tape a band around there so that the coil can't slide down any farther past that tape.
So what he's saying is sorry, this magnet keeps picking up all this stuff. You can run a piece of tape across the top here to hold it in place. Or you can wrap a piece of tape around here so that it can't slide farther down. Which one would you prefer? So let's say for the sake of argument that I had a piece of tape. Like, let's cut a piece of tape. Actually, that's the wrong one. Where's there it is.
And you can try it both ways. So you can try it one way, and if you don't like it, you can try it the other way. We've got plenty of tape on the roll, and you can give each one a try.
Or wrap a band around it this way.
Okay, welcome back, Kate. We're on the taping phase here of our project.
All right, so cut that for me. So we want to keep it centered, right?
So when you're taping here on our project, we have two choices. We can tape it either lengthwise and tape over to hold the coil in place so that when we go to do the final taping, it kind of holds that in the right location. Or we can do it like we did with the straw, where we tape a band. And I would suggest to tape that band at the bottom side of the coil here, where the 1-inch mark is on the tape measure.
No, closer to the end. Not this thing's in, this thing's in. You'll be able to wrap it all the way around. No, there you go. Like that. Now you see what I mean? Don't ball it up. We want to just make a band. There we go. And run it all the way tight, just flush. All right. So see, this is what we want to try to avoid when we're doing that, right? Is that crease? You want it nice and tight. So see how that keeps it from sliding down? That's what he's talking about. Make sense?
Yep.
Okay. Now, when we tape the rest of this, we don't want to be real hard on these, right? We don't want to bend those wires against the things and whatnot. But... Okay.
Okay, our next step here is going to be doing the final taping. And before we start the final taping, we want to make sure, again, all of our components are in the tube and they are pushed in far enough so that the end of the LED, I'll go back here to the LED, is past the end of the tube inside of it to protect it, okay? And again, you're going to twist that around there and to take up the excess wire. You can do that. That's one method, and there's other methods that are available. So what we're going to do is we're going to start taping, and we can tape all the way over the hole where the wires come through out of the tube and a little bit even further up on that tube. And we're going to tape in a spiral all the way down over the tube, over the wires, over the coil, and all the way in even onto the red cap a little bit, okay? We can tape onto the red cap. That'll hold that onto the tube so that it doesn't slide off of the tube ever. And so we're going to tape from that whole location where the wires come through all the way down and over the red cap a little bit so that we do that. And just tape a little bit at a time. If you need to use a little band of tape to help hold the wires down, you can use that method to kind of tape some bands around the wire before you do the final taping, or you can just kind of work with the wires as you do the final taping and tape over everything.
Those we should throw these away. Here, let's just move all this stuff out of the way.
Can I tape?
Nope. I think it's going to work better the other way. Where did our tape go? That's the wrong one.
And it does help to use a two-person method to tape it. One person to hold the tube and turn the tube, and one person to hold the roll of tape and kind of hold the tape stationary. And then as the tube is turning, to let the tape unreel a little bit and give a little bit of tension to pull it tight so that there's not wrinkles in the tape, and you can get a nice, don't pull it real hard, but it does have a little bit of stretch in order to be able to tape over that coil that's a little bit uneven and the wires.
It's okay. They're all going to have some of them, but you know why? So we're going to do one here to get all the wires in place, right? Just keep everything tight.
Yeah, this isn't equal. It's sticking up a little bit.
Okay. We can move it
I also find it helpful to
okay.
overlap the tape about halfway on itself as you tape down the tube. So I believe the tape is a 1-inch wide tape. So if you move the tape about a 1/2 inch, every revolution around there, you're kind of taping over half of the tape to continue down the tube until you reach the red cap.
We're going to run one piece here, just going to hold everything in place. Okay. All right, Snap, do you want to do the tape or do you want to do the tube?
Do I do anything special with the tape?
Well, I mean, we got to keep it even, right?
I think I'll do the tube.
Okay. You got to rotate the tube evenly too. So, all right, you hold the tube.
So do I just rotate it?
So we're going to, okay. We're starting here, right? Now we're going to rotate it around, keep turning. Now, the idea is to get this all nice and clean and even as much as possible. Now, since it's tape, there's always going to be a little bit of overlap, right? Right?
Will we lose points for it?
No. But there's no way to not do it if you're taping it, right?
I know, but over here.
No. That's a good point. Now here's where we gotta be careful. We don't want to mess up these electrical connections, right? So I'm gonna pull out a lot of extra tape so I don't have to pull too hard on them. And we're gonna kind of gently tape this spot, okay? Keep rotating. Good job. Keep going. All right. Now wait, hold it still. The reason I'm pulling there is so that I'm not pulling on these connections, right? All right, keep rotating. Good job. Keep going. Now we're gonna kind of push this down. All right, keep going. Keep going. All right, I'm gonna pull this out a little bit more. All right. Keep going. Come on.
And Kate, how are you doing with yours?
Keep going.
Sorry, I had my sound turned off earlier. So this is Corin. I have Corin here with me.
Okay.
We haven't got our kit yet.
Oh, okay. So you're just watching. Great. Yeah, this will
Yes.
be good. And it will be. I've got two. Well, I have two recordings. I've got one where I go through the presentation just by myself, and then today's presentation, which will
Okay.
actually be about 3 parts because my Zoom meeting's limited to 40 minutes.
Okay.
So hopefully, it says it's converting there, and hopefully it will allow us to put those videos up. I cross my fingers that it is working, and I'll be able to put those videos up, and I'll send out an email with the location on the YouTube
Okay,
channel
great.
for that.
Good.
Yeah, so once we tape up this tube here, then that will complete the project here. And then you'll be able to shake the light again and test it. And you should see that when you shake it, it stays lit and will stay lit for a longer period of time, probably several minutes, if not a little bit longer. And so as you shake the tube, and let's talk about the mechanics of it here, the electrical part of it, and how it works. So again, each time the magnet passes through the coil, we produce a AC waveform, and that's what we see right here. It's a sine wave. So we start at 0 volts, it rises up to some positive voltage, and then the coil allows the magnet to slide back through, and then it produces a negative voltage, and it goes back and forth, and it just keeps on going back and forth, positive, negative, positive, negative. This is the same type of voltage that you have in your household when we turn on the lights. In our house, we have AC voltage, alternating current voltage here. Alternating current voltage is produced, and it makes that waveform as a sinusoidal wave or a sine wave, okay? Now, our little circuit board here has some electronics on it, and again, the electronics are mounted on the circuit board, and the circuit board has copper traces here where the connections are. Instead of using wires or point-to-point connections, these little flat traces is kind of like a little sheet of aluminum foil that's laid on there and glued onto the circuit board. So that allows electricity to flow through from one point to the next. And again, remember, we're using the coil. So the coil is actually, why we call it a coil, is it's wrapped with a special wire. It's a bunch of wire. You could take regular wire and wrap around a little bobbin here, but this is called magnet wire. This is actually produced here in Lafayette, Indiana. We have a plant that makes special wire like this. It's called Ray Magnet Wire. They make wire for motors and for things like a doorbell that has a mechanical plunger in it that moves. This little coil in our electronics is wrapped with that special magnet wire. And what magnet wire is it's a special wire with a coat of shellac or some kind of varnish on it that insulates the wire so that it's not just a bunch of bare copper wire. Otherwise, it would short out and make just a big ball of wire around that coil, and it would not allow you to produce that electricity. Now, we talked about the diode in our project here. The diode allows us to produce AC waveforms and then feed it into the diode. And at the other side, we get what we call a rectified signal or a DC signal. So here, as you see, we've got positive and negative waveforms going in, and this is our coil. And then we feed it through the diode, and then we only get positive, 0 volts, positive, 0 volts. And so that's what the diode does. It makes it like a one-way street, and it only allows the positive voltage spikes to go through. And our last part that we installed here was the capacitor. The capacitor, again, is like a rechargeable battery, and it allows us to power up the LED for a short period of time and keep it burning bright for that short period of time. It's like a short little rechargeable battery. Again, the LED here is the LED is the light emitting diode, and that's what makes our light shine out the end. And LEDs can only work on DC voltage, so that's why we have to have the rectifier or the diode to rectify the voltage from AC to DC. Our resistor is one other important component here. The resistor slows down the flow of electrons. Now, when the electricity flows through, the resistor actually does produce a small amount of heat. If you have a stove that has a little coil on top of it that you cook on, when you turn that on and it turns red, those coils on your stove are actually a resistor. They're producing lots of heat so that you can cook your food on the stove. Okay, so heat is produced every time we slow down the electricity. It also allows the voltage coming out of our capacitor that's been stored up to last a little bit longer. Okay, so it doesn't burn all the energy up at once. And here's our schematic of our project of how it works. So we've got the little magnet, and it passes back and forth across the coil. It produces AC voltage here and goes through the diode. Remember, the diode's a polarized device. The voltage that's produced on the other side is a DC voltage here. And as you see, the resistor slows down the electrons that flow here to our LED, and the LED comes back to the negative side or the other side of our coil. And the capacitor is in here, and this is just like a battery here, so it's storing energy so that if there's excess energy that doesn't go through the resistor, it goes into our capacitor here and stores up. And then when the LED needs more power, it's able to draw the excess power out of the capacitor and use it there in the circuit. One thing that you can go through is the judging sheet, and this is what our judges are going to use to judge your project for the fair. So you can see that they're going to look at the coil to make sure it's centered between the rubber bumpers. And they're also going to make sure that it's taped securely to the tube and that the wires are soldered to the coils on the terminals there of the coil. And on the printed circuit board, they're going to look at the solder joints to make sure none of the solder joints are poor solder joints, that each one of them has a nice little mountain, that there's no solder bridges, and I don't think that you'll have any solder bridges if your circuit is working, okay? And then all your uniform, your joints are uniform in look, okay? And then they'll look at the insulation of the red wires, that they cover the wire up to the printed circuit board. And then the components are positioned closely to the printed circuit board. And then they are placed correctly. So we've got some components like the diode, the resistor, the LED, and the capacitor. And the two wires, we've got the certain specific holes that they need to be mounted in, and they'll look for that. And then they'll look to make sure that there's no damage on the printed circuit board. And they'll look to make sure everything's contained within the tube after you mount everything. And then they'll be able to shake it just like you did tonight to make sure that it lights up. And there is a couple sheets that you can fill out and put together with your project if you would like that. Our county does not require those sheets, but if you have the what I've learned, and you can include that. If it's required in your county, our county does not require it here, but you can put that information there. And here are some of the skills that we worked through tonight. Any questions from anybody tonight?
Do you have any questions?
Well, I thank everybody for joining us tonight. And again, I'll put this up on the YouTube channel so that you can watch it again and see it at any time and review any of the information. And for our fair, we've put together some information that we'll be sending out here about how to exhibit your project or how to get it to the judging. So it'll be kind of like a drive-through. You will drive through the exhibit building and drop off your project for the judge to look at your project and judge it. And it will be available for pickup immediately after it's judged. And I hope our judges are there early in the morning. So as soon as they start judging, we'll start letting you know about your project so that you can pick it up immediately, because they do have to be picked up the same day. Okay?
Awesome.
Well, thanks again for joining us, and contact me at any time if you have any questions.
Thank you.
Thanks again. Have a great evening, everyone.
Okay.